Specialization and the development of bonding processes has been the hallmark of Die-Coat Corporation. For over a quarter century, Die-Coat has led the way in manufacturing single-layer diamond-coated wheels for industrial and medical industries. These include high-production form wheels, hones, cut-off blades, mandrels, and precision medical instruments. In the early 90s, Die-Coat ventured into research and development for concrete block grinding. Using their vast knowledge of coating systems and applied use of single-layer diamond wheels, they engineered a new grinding process using coated diamond drums to grind concrete blocks for the construction industry. Ground-face concrete block and masonry units are finding tremendous growth as architects and specifiers attempt to enhance the appearance and durability of commercial and institutional buildings. Blocks are manufactured in a wide array of colors, textures, and shapes. They also contain various aggregates that can add beauty and patterns to the individual blocks. These blocks allow architects to design attractive, durable structures at a reasonable cost. To further enhance these blocks and make them more desirable as a building material, block manufacturers began grinding the faces to bring out the natural beauty of the aggregate and coloring. These ground-face blocks were an immediate success and viewed as a low-cost process to make blocks not only a durable, inexpensive option, but also a visibly attractive one. The growing trend in the construction industry to offer and use these ground blocks, plus their growing popularity, brought about the need for a cost-efficient and effective method of grinding blocks in a high-production mode. Prior to diamond, the grinding process to expose the block aggregate was accomplished with abrasive belts or bricks. These conventional abrasive methods had many drawbacks. Blocks could not be produced at a high rate because of the rapid wear of the belts, and the surface texture of the blocks varied due to the change in the belt's abrasive surface. With the increased use of ground-face blocks, these two issues required a solution. The answer came from Die-Coat in the form of a single-layer diamond-coated drum. The diamond drum maintains a uniform surface texture and appearance on all the blocks ground, and the production level is dramatically improved. Blocks can now be ground either wet or dry with a uniform texture and appearance, and the block manufacturer has an overall increase in productivity with lower costs per finished block. A concrete block grinding machine utilizes one or more diamond-coated drums to achieve the desired material removal and finish. Multiple drums can be in tandem and step down in diamond size to achieve the desired appearance. These diamond-coated steel drums were developed by Die-Coat and are manufactured with a single layer of saw-grade diamond, like MBS diamond from GE Super Abrasives. This diamond is manufactured with specific wear and performance characteristics to provide extended wheel life and optimum performance in high production operations like block grinding. Typically, to accomplish grinding, the blocks are loaded on a conveyor and move underneath the rotating diamond-coated drums. Sometimes one, but more often 2 or 3 drums of varying diamond size are mounted in tandem to achieve the desired surface finish. Each block now has a smooth texture with a beautiful design of multicolored polished aggregate, adding to the aesthetics of a structure and providing a building material with low maintenance. Die-Coat has developed a state-of-the-art grinder to meet the high production demands of face-grinding concrete masonry products. Designated the DCC Z500, this grinder is a rigid, heavy-duty through-feed grinder capable of any combination of multiple diamond drums and vertical spindle heads for both fast stock removal and fine finishes. Right from the start, this grinder shows its efficiency as sequential power-up of the individual drums helps cut power costs and prevents power surges. A special belt drive system is used to suppress noise for a quiet and user-friendly operation. The grinder has a modular design that allows for future retrofit of up to 4 grinding stations. The DCC Z500 has additional features of a skewed drum configuration for maximum diamond life and a belt and platen conveyor system that can operate at speeds up to 15 feet per minute. This belt design is non-marring, eliminating damage to the finished block's surface. The freestanding control panel permits ease of operation and floor space optimization. From this location, the operator can monitor the machine power and position of individual drum heights and dictate functions of height adjustments, startup, and conveyor operation. The machine also comes with a handheld control unit that allows the operator to calibrate each drum's position with a sensing light to indicate the proper drum location and calibrate the head for an accurate grinding setup. Computerized programming and adjustments for the grinding process can be made rapidly to accommodate blocks up to 16 inches in height. A restrictor bar moves all heads simultaneously up or down as the bar is adjusted. This bar also serves as a safety feature that prohibits oversized blocks from passing beneath the rotating drums. Diamond drum changeover is quick and easy. Belts are removed, a rotating holder is placed beneath the drum, and then the drum is lowered onto the fixture. Bolts are removed, and then the station is raised to free the drum. The process is reversed to mount a new diamond drum. Add to all these features a specially designed coolant delivery system to keep the drums clean and free cutting, and program speeds up to 22 blocks per minute. And the Z500 delivers a highly efficient and productive operation. This rate is the maximum production based on manual load and unload capability. The conveyor speed and grinding capacity of the machine far exceeds manual limitations. Once the face of a block has been ground, a certain number of blocks used for the ends of a wall section must be finished to match the exposed aggregate of the ground face. To process the ends, Die-Coat has developed a standalone end grinder. This machine gives the block producer flexibility for end grinding while not losing valuable production time during changeover of a face-to-end grinding operation on a through-feed system. This grinder is a heavy-duty machine designed to cost-effectively grind ends or faces of masonry units using a single-layer die-coated diamond drum. Its small footprint and ease of operation requires only a single operator and can be used either as a wet or dry grinding system. Depending on the size of the blocks, up to 4 ends can be ground in a single pass. The blocks are simply placed against the backstop and the operator activates the 2 safety interlocks to accomplish the grinding operation. Hydraulic clamps hold the blocks in place and the amount of stock removal is adjusted by positioning of the diamond drum. This unique grinder has the flexibility to also serve as a face grinder, as well as a grinder for special L-shaped blocks. This option gives the block producer the capability to grind a limited number of blocks for architectural design display samples without disruptions to high-production through-feed operations. Additional grinding operations of scoring, bullnosing, or chamfering can further enhance the beauty and functionality of finished blocks. Bullnosing is rounding the sharp edge of a block from a solid. This is done to provide another decorative choice, but also gives a finished look to corners and windowsills. Bullnosing has become a safety requirement for some buildings where the natural sharp edge of a corner would be a hazard to occupants, such as on schools or recreational facilities. A chamfer is a beveled surface used as a decorative option. It also serves a functional purpose by providing a watershed, letting rain run off the side of a structure and away from any joints. This prevents premature attack or erosion on the mortar between the blocks. Scoring is the procedure of cutting a slot into the block face to generate a specific design. The width and depth of an individual slot may vary according to the builder's requirements. Scoring, chamfering, and bullnosing have been done by conventional methods or by precasting. These techniques, however, can be costly and inconsistent. Die-Coat once again put forth significant research and development efforts to design a relatively inexpensive machine using single-layer diamond wheels to cost-effectively bullnose, chamfer, and score concrete blocks to the same consistent high quality achieved in face and end grinding. The machine, engineered by Die-Coat Corporation, is both simple and effective. It is a heavy-duty machine designed for bullnosing, chamfering, or scoring concrete blocks on either the short or long faces. As a standalone unit, it can employ a coolant system for effective wet grinding or incorporate a vacuum unit to alleviate any dust in a dry mode of operation. Blocks are processed rapidly in an easy, highly efficient operation. With a small footprint and ergonomic design, this die coat machine can be located in a small space and requires only a single operator. 3 distinct operations can be performed on this machine: bullnosing, chamfering, and scoring. Each requires a different diamond wheel configuration, but the basic machine operation is the same. Grinding is accomplished by simply placing the block in the holding fixture with the proper orientation to grind the desired edge, clamping the block down securely, and guiding the movable carriage over the grinding wheel. When bullnosing or chamfering ends, instead of the long sides, 2 blocks can be ground at the same time. When performing a scoring operation, it is necessary to change the block holding fixture used for bullnosing and chamfering to add the appropriate spacers for score depth. The block hold-down clamp, which is provided, also has to be installed. Continued production of ground blocks can be accomplished over an extended period. The combination of an efficient machine mounted with a high-performance diamond wheel will provide a typical yield of 130 to 150 short ends or 70 to 90 long sides per hour. Another innovative machine tool is the bond beam saw. Developed by Die Coat to produce open-bottom bond beam blocks, this unit uses 2 diamond saw blades on a heavy-duty motor to cut web sections in standard 6 to 12-inch blocks. Blocks move continuously along a variable speed conveyor for rapid and effective slotting. The efficiency of this machine allows bond beam blocks to be processed quickly without mold changeovers in block production. Die-coated is an industry term applied to Die Coat's proprietary process of attaching diamonds to a wheel surface with a metal coating. This treatment allows diamond crystals to be held securely to the wheel's surface, providing full use of each diamond in a grinding operation. This gives maximum wheel life for a highly productive operation. Die-coated wheels are basically maintenance-free and no dressing is necessary. An additional feature of these wheels is the capability to have the wheel cores stripped and recoated with diamond. This is a further cost reduction for the block manufacturer. The acceptance and demand for concrete blocks as a building material of choice for a variety of structures has been driven in part by the use of textured and colored blocks. Natural beauty of exposed aggregates and the luster of polishing or finishing will continue to be a driving force in the use of these materials. Die Coat has an ongoing commitment to support concrete block manufacturers through research and development in bonding techniques, diamond performance, polishing systems, and concrete grinding parameters to enhance the beauty of ground blocks. At their Michigan facility, Die Coat evaluates power requirements, finishes, speeds, feeds, and diamond to achieve optimum performance in block grinding. A new innovation introduced into the block processing industry is the Die Coat Swarf and Water Reclamation System for wastewater management. This machine uses a slurry dewatering system to separate solid ground materials from the coolant holding tank. Ground blocks are a new way to provide attractive building options at a low cost. Grinding concrete block and masonry units with diamond tooling can be a profitable addition to a contractor's business. Demand for premium-priced ground blocks is on the rise. Learn more about this exciting opportunity and discover how die-coated products can become a new and creative construction option.